This is ASFurther Maths. We are on Unit 4 Vectors, and we're just doing a wee introduction here to vectors. Now, some of your notes, there's a few wee mistakes in here, so we just need to be careful with what we have. Position vectors, unit vectors, and magnitude of vectors are what we're looking at then for the minute. So, first of all, you can see A goes from here to here, so it's going to be 1, 3. So your vector OA, and you can see then there's loads of different ways to write these vectors, and that's really what we're practicing here. The maths isn't really too tough, but what we're doing is kind of that. So you might see it written like kind of OA. That takes you then from O to A. The other way you might see that vector written in as A underlined. And if it's in type, then we do it in bold. So that's kind of what we've done then down here. So we can write these also in terms of i's and j's. So I is a unit vector. I'll explain more about that in a second. I is effectively 1 across. So 2i would be 2 across. And then j is effectively then going up the y-axis. So our vector A goes cross 1 up 3. So that's I plus 3j. And you need to underline your I and your j. And then B is 2i plus j. Unit vectors I and j are parallel to the x and y axis respectively, so that's what I'm saying. So I then is 1 across and so on. The vector OA takes us from here to here, and it's going to be I plus 3j, so those are kind of the other way around, so I've kind of switched them around again. From the diagram we can see that OB, again that's another mistake, that should be B to A. So the vector from B to A is minus 1 up 2. And again, that is another mistake. B to A is minus I plus 2j. And again, you can sort of set it up like this. This is a wee sort of key moment here if you can get your head around this. Note going from B to A is the same as going from... So how do we get then? So look at our diagram, and this is a good way to think of it. How do you get from B to A along routes we know? So we go backwards along B and then plus A. So our vector then from B to A is going to be, you see this here, B to O plus O to A. The vector from B to O is the same then as minus B. And then plus A, or if you want then A minus B. And if you actually then kind of look up and see, our A is I plus 3j. So we're moving up and down here quite a lot. And we're taking away our B, which is 2i plus j. And we kind of join together, not quite our like terms, but just our like variable. We have I, take away 2i, so that's minus I. 3j minus j plus 2j. And of course that was how we got then from B to A. Remember it was back 1 and up 2. So back 1 then and up 2. And that's kind of then where we have it. So that's where I got then. The AB then is kind of the other way around. So let's work out actually our AB. So how do you get from A to B along routes that we know? We would go AO plus OB. That gets you then along the vector. So AO is minus A, and then OB plus B. Our A, reading it up here, so it's minus I plus 3j plus the B, which is 2i plus j. So tidying that up then, we get an I, because you have minus I plus 2i, and then minus 3j plus j minus 2j. So that's the vector that takes us then from A to B. So we reckon it's across 1 down 2. And if I go back up here then, yeah, across 1 down 2. So lots of terminology here. I mean, all we're doing is adding 1s and 2s and 3s here. It's not a big deal in terms of the maths, but the tough bit is getting your head around how we write stuff and how we do different bits and pieces. So I guess things to keep in mind is your vector OA. Another way of writing that is A underlined. If it's in print, then that would be bold. and another way of writing that is I plus 3j. So that's pretty much the basics of what we've done there on that first page. On to the next wee bit. The magnitude of a vector is obtained by Pythagoras' theorem. So again, these might be the right way around, but effectively the magnitude of a vector is the length of that line. You may have done a bit of this before. So how are we going to work out the length of that line? We draw a wee right angle triangle in there, so it's 1 across and 3 up. And when we do Pythagoras, then for the 1 and the 3, remember these are the wrong way around, do 3 squared plus that then is kind of root 10. And we end up with that. Alright. Some basic operations then on vectors. So a plus b, nice and straightforward. So how do we write this? Obviously they're in bold because they're in print. We write them then as a plus b, and that's going to be 2i plus 5j plus 4i minus 2j. That gives me 6i plus 3j. A minus b. We write a minus b, remembering to underline, and in this case then we go 2i plus 5j, take away 4i minus 2j, gives us then, of course, 2i take away 4i is minus 2i, and then 5j minus minus 2j is plus 7j. Part C then is 2a minus 3b. So that's going to be 2 upon 2i plus 5j, take away 3 upon 4i minus 2j. That obviously gives me 4i plus 10j, take away 12i. What way am I doing this? So we're going to go 12i minus 6j. Just being careful with the negatives, I suppose, is all we're saying. 4i take away 12i is going to give us minus 8i, and then 10j minus minus 6j is, of course, 10j plus 6j. So that gives me plus 16j. Next then is unit vectors, and it brings in our Pythagoras thing where we're trying to find the length of a vector then as well. So unit vectors then that are not parallel. So I and j are unit vectors parallel to the x and y axis, but a unit vector in a general direction of a vector A is denoted by A, so it's A with a wee pointy hat. A unit vector is a vector in the same direction as the original vector with magnitude 1. Thus, to find the unit vector, we divide the vector by its magnitude. So the unit vector of A, sorry I got disturbed there, so the unit vector is the vector itself divided by its magnitude, and its magnitude, of course, we do that by working out then the Pythagoras bit. So first of all then find the magnitude. So the way we write magnitude is like this. Of course we have a type, so there's actually 3 lines around that, and in this case that's 3 across and 4 up, so we're going to do square root of 3 squared plus 4 squared. I think most people know that that's going to give us 5. So the magnitude, the length of this vector, if I was to draw it out, would be 5. I need to find the unit vector of this, so I would go to the actual vector and then divide it by 5. So it's quite straightforward. The unit vector then is the vector itself divided by its magnitude. So the vector itself is 3i plus 4j, and its magnitude then is 5. That would pretty much kind of give you your final answer. Another way of writing it, if you wished, would be a fifth upon 3i plus 4j, or another way again would be 3/5 I plus 4/5 j. Any of those are fine. So what have we found out here? The vector 3i plus 4j, so 3i plus 4j is kind of like that. The length of that vector is 5, but we want the unit vector of that, so we need to make it 5 times smaller. So that then is going to be 3/5 I plus 4/5 j, or one of the other forms. A unit vector of a particular vector is a vector going the same direction, but just of length 1. If you then think back to what I and j actually are, they are unit vectors because they're of length 1. So I is of course 1 across. That's why they're called unit vectors, and they're the ones that are parallel then to the x and y axis.